Dear student, to continue this chapter, transition element, I had discussed in the previous lecture, introduction of transition element, variation of the radii of the transition element along the period and along in the group. And so many cases has been explained. And in the third lecture, I discussed about the ionization energy and ionization energy, how it vary the ionization energy along the period 3D, 4D and 5D like that. And there are so many exceptional cases of ionization energy, and high ionization energy depends upon electronic configuration. Keeping the time factor is mind, now I would like to continue. The next topic is electrode potential. Electrode potential, that is electrode potential and electrode potential, that is for M2 plus to M, it's a variation, and electrode potential for M3 plus to M2 plus and the reactivity. And what is the reactivity on the basis of this three? This is on the basis of the electrode potential. This is very important question asked from this part. So the concept is very essential to answer such questions. So we just take the concept in that content. Already this chapter is very important. Now the ionization energy gives a clue about the stability of a compound in a of the transition metal, and that form a compound in a solid state. As for example, if we take nickel 2 plus and we take this is a platinum 2 plus, platinum 2 compound and nickel 2, and that is the sum of first two ionization energy, i.e. H1 and plus 2. Simply we write this. So this ionization energy, it is a calculated value. So it is given, suppose it is 2.49 into 10 to the power 3, and this is suppose 2.66 and this is 3. Unit is kilojoule per mole if it is written. So what clue it gives? The ionization energy gives a clue of the stability of a transition metal in a particular state. Which state will be stable in the solid form? Nickel 2 and platinum 2. So lower the ionization, lower the, that is sum of ionization energy, sum of ionization energy, and greater the stability. Sum of ionization energy, greater the stability. Greater the stability. This is. So, if the value is not given, that's a value for your concept. If sum of first two ionization energy, if in the literary question there are two metals in the different state, in the same state, nickel and platinum, and out of these two, which one will be more stable? If one will have lower ionization energy, the sum of two ionization energy, and the another one will have the sum of higher sum of two ionization energy. So the concept, the sum of ionization energy. This is sum of ionization energy, first two ionization energy, greater the stability. So we can say that out of nickel 2 and platinum 2, nickel 2 is more stable. Now if we compare the ionization energy delta H1 delta H2, delta H3, this is delta H4, this one. Now the sum of ionization energy for 4, if we consider, and then if it is considered, that is for platinum. Again the concept is same, lower the ionization energy and greater the stability. If the value of platinum 4, and it is said that why platinum 4 is more stable, more stable than nickel 4. Nickel 4. The reason is very clear. If we take the sum of first 4 ionization energy for nickel 2, and we take the sum of first 4 ionization energy for platinum 2, which sum is lower, that state will be more stable. So if we compare the energy, then it is for nickel 4, this is platinum 4, 6.70, suppose it is 10 to the power 3 kilojoule, and for nickel 4, 8.80, 10 to the power 3 kilojoule per mole, like that, kilojoule per mole. So obviously lower the energy, then greater the stability. That's why out of nickel 4 and the platinum 4, the platinum 4 is more stable than that of the nickel 4, right? And the compound that is just in the platinum 4 state, that is K2PtClF6, here the oxidation state, this is. So this is gives the clue of the stability of a transition metal in a particular oxidation state. This is called the thermodynamic stability of the transition element in the solid state. Now we take the stability of the transition metal in a particular state in aqueous solution. Then we have to consider the electrode potential, that is the reduction potential, and we may consider also the oxidation potential, because reduction is just the reverse of oxidation. So suppose we take, so this electrode potential value, when we consider, not only depends upon this will depends upon the 3 factors. So in aqueous solution, the stability of your particular oxidation state of the transition metal depends upon the total enthalpy change, or called that is the electrode potential value. Lesser the value, that is more negative the electrode potential value, then that oxidation state will be more stable in the aqueous solution. This is the concept. So we consider here, this is M plus and this is aqueous, and this is called total enthalpy change. This is equal to M plus and aqueous. This one, so this M aqueous, this is M plus aqueous. So it comes here M solid, this is delta H sublimation, and this is comes to be delta H1 plus delta H2. This is M, this is 2 plus aqueous, and this is Mn plus. Simply we said M2 plus Mn plus, and here delta H hydration, delta H hydration, that is equal to this one. This is. So this is called, this is ionization enthalpy. This is delta IH, delta IH. Ionization enthalpy, the energy required to remove the electron, to convert into the, that is ion, and this ion react with the, that is water, get converted into their aqueous solution. So this is a Born-Haber cycle. And now the total enthalpy change, delta HT, is depends upon delta H sublimation, that depends upon delta H ionization, plus depends upon, that is delta H hydration. So this is very important line, and this total enthalpy change will decide the value of the electrode potential if it is in standard condition. What is the standard condition? That we take the solution of 1m and the temperature kept to 298 Kelvin temperature, and that is pressure, that is 1 atmospheric pressure. So in these first two steps, here energy required. Here energy required. This is positive. And here also energy required. In short, we write positive. And here the energy released. Here energy released. Here energy released. So if the energy released, that is taken as this is negative. So electrode potential value, that is, if we consider here, suppose we take for nickel, this nickel get oxidized. This is nickel 2 plus twice E, and this is and we take zinc, this is Zn2 plus, and this is twice E, right? Now its oxidation potential, E oxidation, because it is undergoing oxidation, so we take it oxidation, and the value of, this is the value of reduction potential, and if we do it considered as the oxidation, then its value is that is 0.25. This is 5.25. This is the oxidation potential is considered as 0.25, right? And if it is in standard condition, then it is this one. And its oxidation potential value is considered as plus point with 7.6. This is the value of the reduction potential. So here what will happen? Higher the oxidation potential value, more the tendency to lose electron. The standard SOP, standard oxidation potential. Here we consider SOP. This is a standard oxidation potential. Now the standard oxidation potential here is less and here is high. So this, its reduction potential is considered, then it will be less. If SRP, standard reduction potential, is considered, then it will be less. And if it is considered, then it will be SRP, standard reduction potential, will be high. So the stability of a particular oxidation state in aqueous solution will depend upon the total enthalpy change or on the value of standard electrode potential. If the standard electrode potential is, that is less, but low, that is less means low, and low means that is more negative, then that state will be more stable. So if we consider as in, this is nickel 2 plus, just phenomena will be just reverse, that is 2 plus nickel. So this is SRP, that is more, SRP is less, that is more negative, and more negative means they will act as a reducing agent. They will act as a reducing agent. They will act as a powerful reducing agent, and they will act as a oxidizing agent. So if we consider here as its reduction potential value, then we see why zinc will lose electron. This is 2 plus and twice E, and this is here E0 reduction, that is equal to minus 0.76, and this is the nickel, and this is nickel 2 plus, and this one is 2, and this is reduction potential. Then it was positive, then it is minus 0.25. So which one is more negative? This is the concept. So which one is more negative? This is zinc. So zinc will have more tendency to lose electron, and zinc will act as a reducing agent, because the phenomena is oxidation, and this is also the oxidation. So out of these two, which metal is more reactive? It is asked. that can be decided on the basis of the reduction potential value. So if the reduction potential value is lower, more tendency to lose electron and it will get oxidized, and that metal will act as a reducing agent. So this zinc will act as a reducing agent in this one. So its value out of zinc and zinc 2 plus and nickel and nickel 2 plus, zinc is more reactive than that of that is nickel, because out of these two, this is more negative. So more negative will act as, that is the reducing agent. So zinc will act as a good reducing agent than that of the nickel, that is nickel. Is it clear? Now, so the question is here. So one thing we know, more negative the SRP and lower the SRP, that is more negative, will act as reducing agent. And this will another, that is SRP is higher, so they will act as oxidizing agent. Now let us proceed in the next one. So what we see, just we see the electrode potential. So when we talk the electrode potential value of the transition metal, so we consider from metal to M2 plus and another M3 plus to M2 plus. So in the first, the variation, this is M2 plus, this one, the variation in the value of the electrode potential is not regular. First point, variation is not regular. Variation in the trend is not regular. Is not regular. Why it is not regular? This question is asked, and we have to, this is minus 1.6. So when we go from left to right in the first transition series, the electrode potential value for M2 plus 1 going to be less negative, except here the copper is positive. So we talk that why copper will have another question, that is why copper has positive electrode potential value. Why E0 for copper is positive. Copper is positive. And we consider that is manganese, nickel, and this is zinc. Third one is manganese, nickel, and zinc have the high negative value. Well, this aspect should be explained here. Why there is a not regular trend? Because the electrode potential will depend upon the three factors. These three factors, that is enthalpy of sublimation, sum of ionization, because why we take here the ionization energy? Here M2 plus means to remove the two electron. That's why we take the ionization energy first and the ionization energy second. So this series is not regular because the electrode potential will depend upon the three factors. These three factors are there. This depends upon the three factors. This depends upon the three factors, that is enthalpy of sublimation, sum of ionization energy. 2 की बात करें तो that is ionization energy 1 and ionization energy 2 and the hydration enthalpy. Because the sum of sublimation energy and the ionization enthalpy are not regular. That's why the E0 M2 plus M is not regular. So irregularity is due to the irregularities in the enthalpy of sublimation and the sum of ionization enthalpy 1 and the 2. This is the reason, that's why the value is not right. Now the another factor, why E0 for copper 2 plus and copper is positive. Why it is positive? Again, this two factor is very important. Why it is positive? Because in this step energy is required. In this step energy is also required. And in this step the energy is released. So it is taken as the negative. So the energy required and released. Why it is positive? If the the released energy not compensated the energy required, रिक्वायरमेंट ज़्यादा है और एनर्जी रिलीज कम हो रहा है, इसीलिए मैग्नीट्यूड पॉजिटिव हो जाता है. तो व्हाई इट इज पॉजिटिव? बिकॉज द एनर्जी required bracket में, that is enthalpy of sublimation, and delta IH1 and delta IH2 is not compensated by enthalpy of hydration. That's why this is the value of copper is in the first series, that is what that is plus 0.34, and the zinc will have the negative value. So those elements having the negative value, they are active and have tendency to form as a, that is to act as a oxidizing agent. They will just say, suppose we take vanadium 2 plus, chromium 2 plus, etc. So they will act as a oxidizing agent when react with, so it can. So that is they will act as let us we see the value. Let us we see with the value, then we give the statement. See, other aspects, this one. That is for nickel, manganese. Nickel, third aspect, that is manganese, nickel and the zinc. The value here is manganese is minus 1.18 volt and the nickel is minus 0.25 and this is minus 0. So it is this is Mn. If we consider as Mn, so Mn will lose electron and this is twice C. And if we consider Zn, then it is Zn2 plus and this is twice C. Its configuration is 3d5 and this is 3d10. So that is all these two will have more tendency to lose electron. Means SOP will be more, SRP will be, if it is more, then SRP will be less. So its SRP will be standard reduction potential. Here the value D5 is more stable, D10 is more stable. That's why nickel, manganese can easily lose the electron, and in that condition, this manganese and the zinc will act as a reducing agent, and it will have, because its electrode potential is negative, means they will act as a reducing agent. And who will act as reducing agent? They will those who will have the less SRP, that is less negative, less means less, that is more negative. That's why its value is negative. Now what is about the nickel? If we take about the nickel, this is nickel 2 plus and this is twice C and this is 3d8. Here there is no stable configuration. So how we say the nickel will get converted into nickel 2 plus and it will have the negative reduction potential value. The nickel, this question is asked, this Mn, so you will answer that Mn is converted into 3d5, more tendency to lose electron, to attain stable configuration. Zinc will have also tendency to lose electron, to attain that is stable configuration, and these are reactive, lose electron, so it will act as a, and that is what? That reducing agent, Mn and this one, because if it lose electron, the metal will act as a reducing agent, because this will have the less SRP, less SRP मतलब more negative, More negative means tendency to lose electron. If you get confused, then you quickly consider copper 2 plus, that is plus 3, 4 plus volt. And if you will quickly consider Zn2 plus and Zn2 plus. So, lower the reduction potential value, means more negative the reduction potential value, more the tendency to lose electron and get oxidized. That's why here, if you will see the value, so Mn and zinc, anybody ask you why it will lose electron? By seeing the electrode potential value, because it is negative, they are active and they will lose electron. If they lose electron, then it is oxidation and the process is said to be the reduction. Is it clear? So the agent is called the reducing agent. What about the nickel 2 plus? Here there is no stable configuration. Why it is will have the negative value? This one. So in question it is asked, Mn, nickel and zinc will have the negative electrode potential value. Negative electrode potential value, and this value is due to the high enthalpy of hydration, because the electrode potential will depends not only these two factors, it also depends upon the enthalpy of hydration. So nickel 2 plus have the negative electrode potential, that is SRP. It is due to high enthalpy of hydration. Enthalpy of hydration. So we conclude for the variation of the first two. First is variation is not regular. This irregularity is due to the irregularity in the sum of enthalpy of ionization and the enthalpy of this is a sublimation. Second factor, copper is positive. Because copper is positive means the energy required is not compensated by the energy released in the step of enthalpy of hydration. Third factor, why the Mn, why the nickel and the zinc will have the negative electrode potential value, that is not M2 plus, that is Ni2 plus N, and this is Mn2 plus M, and Zn2 plus this one. So this Mn is negative, zinc is negative due to its stability in configuration, because they will have more tendency to lose electron, and if it lose electron, the metal will act as a reducing acid. This one. Now nickel will have no stable configuration. Still the question asks why it will have the negative value. So this will depend upon this factor. So you look at the factor. This is the hydration. So hydration enthalpy, due to the more hydration energy, hydration enthalpy, and hydration enthalpy, the term is considered negative. That's why nickel will have the negative electrode potential, although it is low. Now we take the trend of the third. Keeping in mind the time factor, that is third. Now we take, that is the question is asked Mn2 plus. So we compare from metal, that is oxidation state 2, and another from 2 to 3. 2 to 3. Now question is asked, that is Mn, this is 3 plus and Mn2 plus. This one and this value, and similarly we consider that is Fe3 plus, Fe2 plus, this one. So its value is 1 point. So higher the reduction potential value, more the tendency, higher the reduction potential value. If the value is positive means this Mn2 plus, Mn3 plus, 3d5, think here, this one. So is it possible for Mn2 plus to lose electron? Because here SOP is less, because the manganese 2 plus is in the stable state or stable configuration. It don't want to lose electron, right? So its SOP is less SRP will be moved. Means this Mn3 plus will take up electron and get reduced to Mn2 plus. This is 3d4 and this is 3d5 and this one is stable. So this will, and this process is going on, reduction. So this Mn3 plus will act as a oxidizing agent. This Mn3 plus will act as a oxidizing agent. So question asks, out of these two couples, this one, why Mn3 plus, and we will have the higher value of the reduction potential. Again, due to the stable configuration of this is 3d5, because Mn2 plus is 3d5, it will have less tendency to lose electron. So rather this Mn3 plus will have more tendency to gain electron, and it will attain the stable configuration. That's why as it gains electron, so it will act as a reducing agent, right? Similarly, if we take about chromium 2 plus, and this is iron. Suppose we take iron 3 plus and iron 2 plus. So this iron is 0, this one. So iron 2 plus. So it is iron 3 plus and this one. So this is a 3D what? So this is 3D 5 and this 3D 6. What are the research of this 3D 5? So it will have tendency, it will have more tendency Fe3 Mn3 plus to this one, but this Mn3 will less tendency to take up electron to convert Fe2 plus, because it will not unstable. Rather, this Fe2 plus get oxidized to Fe3 plus to attain the stable configuration. So here this Fe2 plus act as a what? That is oxidizing agent. This is will act as a, this is reducing agent. Fe2 plus is reducing agent. So if question asked, out of Mn3 plus and Fe3 plus, this Mn2 plus acts as an oxidizing agent. Why? Fe3 plus, that is Fe2 plus acts as a reducing agent. This one. So the stability in the plus 3 state, that can be checked by seeing the value of the strong potential. So this will have this one. Now similarly it is said that is Mn2 plus. Mn2 plus, similarly we take cobalt 3 plus and cobalt 2 plus, like that. Now is the reactivity. Reactivity, we tell about the reactivity. Now lower the reduction potential value, means negative the reduction potential value, they will act as a reducing agent. Reducing agent and reduces, that's why zinc will react with acid and it gets converted into zinc 2 plus, and this is hydrogen. Because the copper will have E0, copper 2 plus copper, it is positive 0.34 volt. So this H plus will no reactions, will dilute H2 or dilute H plus. It will react. Why? Because zinc will have less SRP, means negative value, so it is more reactive. So how it will react, let us see. So zinc Zn2 plus, and this is electron, and this H plus comes from where? This is HCl, this is H plus, and this Cl minus, and this H plus accepts electron. If 2H twice E, then it will get the H one. So any reactive metals, so will react with acid, liberate hydrogen, and copper will not liberate hydrogen because copper is less reactive, and zinc, because copper's electrode potential value is also positive and its value is also, that is zinc value is negative. So zinc will liberate hydrogen from mineral acids. Like that of reactivity means Mn3 plus acts as a what? This is called oxidizing agent, right? So this will depends upon the reactivity. Now this is a copper, this positive value, so it will not react with acid because it have no tendency to lose electron and react with, although it reacts with concentrated acid. This one, this is one of the reason. So this is all about the electrode potential, how it vary. The question, its variation is irregular, is 0 for copper is positive, and why Mn3 will act as a reducing agent. Now one thing is left, suppose we take D4, and this D4, that is Mn3 plus, and this is chromium 2 plus. Now this D4 configuration, and it is said that this will act as a oxidizing agent, and it is said that it will act as a reducing agent. Again decided on the same value, because this will have lose electron, gain electron, 3d5, and this will have chromium 3 plus, this one. If you will see the value here, chromium negative, so it will have tendency to lose electron, right? And it is positive, it will have tendency to gain electron. Now here it is oxidation, here it is reduction, and here the configuration in 3d3. तो फिर आप पूछेंगे कि सर 3d5 में तो स्टेबल था, 3d3 कैसे स्टेबल आ गया? 3d3 भी स्टेबल है because D have 5 boxes, 1, 2, 3, and the 3 electron, and this is called T2Z3 and EG0. This is also a symmetrical configuration. That's why chromium out of chromium 2 and chromium 3. So question is asked Mn3 plus and Mn as a oxidizing agent. Similarly, beryllium 2 plus will act as a reducing agent. And this question is answered in a way. So this is all about the variability of the electrode potential. The reactivity depends upon the electrode potential, and that's why we can say Mn3 plus acts as a reducing agent, oxidizing agent, and here and chromium 2 plus, titanium 2 plus, vanadium 2 plus, they will act as a reducing agent. So this is the conclusion about the reduction potential value and its variation in and its stability in aqueous solution. Concluded that electrode potential will depend upon the 3 factors. Always remember, if you will have the knowledge of these 3 factors, then you can easily define why it is positive, why it is negative. Sometimes it is irregular because the variation of this. Thank you. Next topic will discussed in the next lectures.